Dear students, welcome to class 12th chemistry. Here we are starting with a presentation which is introduction for the chapter Polymers. The learning objectives are, after studying this unit, you'll be able to explain the terms monomer, polymer and polymerization, distinguish between various classes of polymers and different types of polymerization processes. You'll be able to appreciate the formation of these polymers from their monomers and their importance in our daily life. You'll be able to describe the preparation of some important synthetic polymers and their properties. So we start with some important terms like monomers. These are simple and reactive molecules which combine to form polymers by forming covalent bonds. Polymers. They are very large molecules, also called macromolecules, as they have very high molar mass and they are formed by joining of monomer units by covalent bonding. Polymerization. It's the process of formation of these polymers from their respective monomers. As mono is one and poly means many, hence the terms are very clear. Classification of polymers can be done on the basis of the source, structure, mode of polymerization, molecular forces and growth polymerization. The first classification is based on source. We have three categories under this. Natural polymers. They are found naturally in plants and animals. For example, proteins, cellulose, starch. Semi-synthetic polymers. They are formed by modification of the naturally occurring polymers. As you can see in the example, rayon, which is cellulose acetate. It is formed by the modification of naturally occurring cellulose. So you can say it's a derivative in terms of chemistry. It's a derivative of the naturally occurring polymer cellulose. Synthetic polymers, the third category, they manufactured artificially, that is totally man-made polymers. For example, nylon and polythene. Second classification is based on structure of polymer. As you can see here in the diagrams, figures, the linear polymer has long and straight chains. The branched polymers, they have branching in their chains. And cross-linked or network polymers, they are formed from bi or trifunctional monomers. That is, the monomers having 2 or 3 functional groups in them, which can help them in the cross-linking of the chains. Examples you can see here, HDP, high density polythene, and PVC. And second category has example LDP, low density polythene. The reason for HDP and LDP here is, as you can see, in linear polymers, the chains are not having any branching. So in the given volume, in the given space, we can stack more long chains. That means the volume will remain the same, but mass will be more. So density is mass upon volume. And in the second case, low density, because in the same volume, if you compare with the first one, you can put less number of these chains with the branches. So the mass will be less. Hence the density will automatically be less. Next category is classification based on mode of polymerization. That means what type of reaction is being followed for the formation of polymer. There are two types of reactions basically, addition and condensation. In addition reaction, it's formed by the repeated addition of monomer molecules which have double or triple bond. Polythene is an example, and we have done this reaction in the organic chapter of class 11th also. And condensation polymers are those which are formed by repeated condensation reaction. That means when the reaction is taking place, small molecules like water is eliminated. We'll be doing all these reactions later. This is just the introduction and classification. So here in condensation polymers, the units, they are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. I hope you understand the meaning of bifunctional or trifunctional now. That is the monomers having two or more functional groups in them. Addition polymers can again be classified as homopolymers and copolymers. Homopolymers means if they are having the same single type of monomer, many units of only one type of monomer. For example, polythene again, it's ethene only. You take many units of ethene, n number of units, and they polymerize by addition reaction to give you the polymer. And copolymerization, the copolymers, they are formed by the repeated addition of two different monomers as shown here in the reaction. The reaction is between butadiene and styrene. These are the two starting materials, and when they react, the condensation, the not condensation, sorry, it is basically the addition reaction only, but here the different monomeric units are being taken. Students often get confused between copolymers and condensation polymers, so I must make it very clear here. As I also said, condensation here, it's not condensation, it is basically the addition reaction, because here you can't see any small molecule like water being eliminated after the reaction is taking place. That can happen only if you react molecules like the formation of ester. When carboxylic functional group reacts with alcoholic functional group, they get joined by ester linkage and water molecule is eliminated. That is condensation. So copolymers can be formed by condensation reaction also. They can be formed by addition reaction also. Here it is addition reaction giving rise to this copolymer. The next classification is based on molecular forces. As the categories are elastomers, they have elasticity in them, elastic properties, so they are rubber like solids, and they are stretchable because they are held by weak intermolecular forces. For example, neoprene, Buna S. The second is fibers. Fibers are thread like solids. They have very high tensile strength and they have strong intermolecular force. That's why they can't be stretched like elastomers. Examples are polyamide and polyesters. Next is thermoplastic, and the last is thermosetting. I'm talking about them together because often in the papers and everywhere they ask you to differentiate between the two or compare the two. The thermoplastic polymer, they are linear or slightly branched long chain molecules, but thermosetting polymers are cross-linked or heavily branched ones. Thermoplastic, they possess intermediate force of interaction, that is between elastomer and fiber. But in case of thermosetting, you have intermediate force of attraction like in thermoplastic. So we can't say this is a difference, but yes, the difference is in the branching, heavily branched and slightly branched only. Then thermoplastic polymers, they are capable of repeatedly softening on heating and hardening on cooling. That means they can be molded again and again into different shapes. But thermosetting on heating, it undergoes extensive cross linking and you can't mold it again and again. That is, it becomes infusible, which you cannot soften and mold again and again. The examples are given here. Thermoplastic, for example, polythene, polyvinyl, and thermosetting, bakelite, and urea formaldehyde resins. Now, some of the examples may not be familiar, so don't worry about it. We are going to study about their reactions in detail later in the chapter. And one more thing, this is only the introduction and classification of the chapter. Once you do it, as I sent the message on Snapworks also, once you do it from here, please read it, do it thoroughly from NCRT till this classification point only, and then do the in-text and exercise questions in your chemistry register. After that, I will send an assignment in the form of a worksheet maybe, so that you can revise whatever you have done till this point, and then further we'll take up the next topics followed by an assignment on the whole chapter. Thank you.